Lesson 1, angles. So when we're dealing with sinusoidal functions, we start talking about radians as well as angles. So radians up till now is probably all you remember is it's on your calculator and it'll screw up your trigonometry if you're in that function. But what a radian is it's the measure of the central angle of a circle subtended by an arc that is the same length as the radius of a circle. And now that sounds really confusing. But what it means is that this is our radius. If we were to take an arc that is the same length as this radius, it would be till about there. Now if you're not doing this with the video, I will give you a manipulative to learn this so that you can actually see that those are the same lengths. So if you have an arc that's the same length, and then if you have also another radius, this would be the same length. So what a radian is it's this degrees right here. How many degrees that is. And there's a couple ways that we can learn it. But first of all, to just look, if you were to take a line right here, it would be roughly the same size. And because all of these are the same length, this would be an equilateral triangle with all equal sides. So often we can remember that the angle of a radian is approximately 60 degrees, and that is rounded. We don't use it often, but it's a good way to see how that happens. If we were to continue our radians all the way around, it would fit 1, 2, 3, 4, 5, 6 and a bit. It should fit a little bit more than 6 times around. And that is it's how we've used the radius to find the circumference of a circle. So whenever you find the circumference of a circle, it's c is equal to 2 pi r. So 2 pi times the radius. And the reason for that is that when you make one full revolution or one circle, this is 2 pi radians. It's the circumference. 2 pi times the radians. So this is why we use radians. It's dealing with actual measures for a circle. It doesn't matter what your r is. We just call it a radian. So a full circle is 2 pi radians. So that would mean that half a circle is 1 pi radian. We also know that 2 pi radians is 360 degree rotation, and 1 pi radian is 180 degree rotation. So we can also use this relationship to convert between angles and radians. So 180 degrees is the same as pi radians. So we use this relationship to convert. So if we wanted to find out how many degrees are in 1 radian, we'd put an x on the top, cross multiply, and divide. When you cross multiply and divide, you should get x to be equal to 57.3 degrees. So this isn't really 60 degrees, it's 57.3. We can approximate it to be about 60. So to convert between radians, we can use that relationship every time. So we would go 180 over pi is equal to, and because this is degrees, we would keep the degrees in the same spot. So 45 goes on top, x goes on the bottom, cross multiply and divide. And make sure you are using your pi button and not 3.14. Do not do that ever. There is a pi button on your calculator for a reason. You use it. You should get x to be equal to 0.79. So 45 degrees is 0.79 radians. We often round this to be 0.8. Same thing here, 180 degrees over pi is equal to 60 over x. Cross multiply and divide. You should get x to be 1.05 radians. So I want you to pause the video and figure each of these out. Okay, so you should have set up your fractions like this. Cross multiply and divide. For 90 degrees, you should get x to equal 1.6 radians. For 180 degrees, cross multiply and divide, you will obviously get x to equal 3.14. We often round this to be 3.2. This one we cross multiply divide, x is equal to 4.7. And the last one, cross multiply and divide, it should be double this one, which would be 6.28. We often round with this number to make it 6.4. So there's a little bit of rounding here. These are approximations that we use. So when you flip the page to your second example, we are going to make what is called a unit circle. So what a unit circle is it helps us to make estimations. And I know on your assessment you have to be able to fill in an entire unit circle, and you have to be able to use this for approximations. The point of this is to become familiar with all of these different angles and different radians, and the more you do it, the easier and more natural it will become. So first, what we're going to do on the unit circle is we're going to label all of the degrees. So starting here, this is 0 degrees. You might want to write small because you're going to have to write a lot. That was in the wrong spot. This next would be 30 degrees. The next one would be 45 degrees, and the last one would be 60 degrees. Our next solid line is our 90 degree spot. So notice that all of the dotted lines are going up by 30, and the solid lines are going up by 45. I want you to pause the video and fill in all of the degrees for the circle. So what you should get for the next one is 120 degrees, then you will have 135 degrees, then you will have 150 degrees, and from this point on I'm going to show you a quicker way to label this if you have trouble with it. The threes are easier. So if you want to just go up by threes, this goes 3, 6, 9, 12, 15, 18. This would be 21, so 210. 24, which is 240, 27, which is 270, 30, which is 300, and 33, and then 36. So labeling your 30s is not very hard. Now we need to just go in and add in our 45s. So from 180 plus 45 is 225, and our last one is 315. The more you do this, the more familiar those numbers will be. Alright, now what we're going to do is we're going to go through and fill it in with decimals for our radians. So for 0, it'd be 0. We're going to remember that 30 degrees is 0.53 radians. It's also the same as 1/6 pi. If you were to split it, this would be 1, 2, 3, 4, 5, 6. There's 6 sections there with 30s. So it's 1/6 pi. Another important number is 45 degrees is 0.8. And if we look at it, there's 1, 2, 3, 4 sections, so it's 1/4 pi. 90 degrees, 90 degrees is 1.6 radians, and if you look at it, it's 2 sections, so it's 1/2 pi. And I think that's all you need to remember. 1.6, 0.53, and 0.8. So 0 is 0 radians, 30 degrees is 0.53, 45 degrees is 0.8, and 60 degrees would be 0.53 times 2, which is 1.06, and 90 degrees is 1.6. So I'll show you a trick on how to fill this in. Every 0.8 will be 45 degrees. So 0 plus 0.8 is 45 degrees. 0.8 plus 0.8 is 1.6 degrees. 1.6 plus 0.8 would be our next 45 point, which would be 2.4. It's kind of just like counting by eighths. If we add another 0.8, it would be the same as 32, so 3.2. The next one would be plus 0.8, which is 4.0. Add another 0.8 and you would get 4.8. Plus 0.8 is 5.6. And plus 0.8 is 6.4. So that is how you can go in and count by your 45s. It works the same way with your 30 degrees, except you have a little bit of rounding. So for your 30 degrees, you start with 1.6. When you add 0.53, you get 2.13. When you add another 0.53, you get 2.93. And when you add another 0.53, it doesn't quite get you to 3.2, but we're going to round here to 3.2. Now, starting at the next section, start with 3.2 until you get to here. So pause the video and see if you can fill in those numbers. So you should get 3.73, 4.26, then you would have 4.8. Then starting at 4.8, you would add 0.53, and you would get 5.33. And for 330, you would have 5.86. And then the last one, plus 0.53, would get you to 6.4. Now what we're going to do is we're going to do this as fractions. And I know how much everybody loves fractions. But this isn't hard. So this is still 0 pi. This is 1/6 pi, and now we're just going to do the 30 degrees. So when we start at 1/6, every section is a sixth. So this would be 1/6. The next one would be 2/6. And you can simplify that to be 1/3. The next section would be 3/6. Okay, this is hard. Which can be simplified to 1/2 pi. The next section would be 4/6. And so on and so on. Pause the video. I want you to fill in all of the sixths. So what you should get is this is 5/6. This one is 6/6, which is 1 pi. This one would be 7/6. This one would be 8/6, which is the same as 4/3 pi. The next one would be 9/6. Don't forget to go to your 90 spot, which would be 3/2 pi. Then you would have 10/6, which is 5/3 pi. Then 11/6, which is just 11/6, and 12/6, which is 2 pi. So you're just counting. That's all fractions are. Now we're going to do our 45s. So for 45s, this is 1/4 pi. This would be 2/4 pi, which is 1/2 pi. This would be 3/4 pi, and this would be 4/4 pi, which is 1 pi. This would be 5/4 pi. This would be 6/4 pi, which is the same as 3 over 2. This would be 7/4 pi, and this would be 8/4 pi, which is the same as 2 over pi. So that is your unit circle. You do need to fill in the entire thing. Alright, now we are going to estimate the value of each angle in radian measures. When it says estimate, I'm assuming you need to use 45 degrees is 0.8, 30 degrees is 0.53, 90 degrees is 1.6. So you're using the unit circle. You also need to be able to draw an angle. So 150 degrees, always start with your radius. 150 degrees would be in this section. The way that we draw this is you start with your first radius and draw an arrow to your other arm, your other radius. So this is 150 degrees. If we were to look at 150 degrees, it's the same as 180 minus 150, which is 130 degrees. And by 130, I mean just 30. So, if you take 180 degrees and subtract 30 degrees, you'd be left with 150. So we start with 180 degrees, which is 3.2. We're going to subtract 30 degrees, which is 0.53, and we should be left with 180. So if you want to see it this way, it'd be minus 30 is 150. So you should be left with 2.93. So that is how you would estimate 150 degrees. For the next one, we have 240 degrees. So to draw this, you would start at 0, and 240 would be on this side. Your angle goes like that. So 240 degrees would be the same as 270 degrees minus 30 degrees. And you would get 240. So 270 is 4.8, 30 is 0.53. You should get 4.26, and that's right on your unit circle. So for these, remembering 90, 180 is 3.2, 270 is 4.8, and 360 is 6.4. Those are the most important ones to remember. So remember these. Okay, for C, 450 degrees. So this is more than one circle. So if you went one circle, that would be 360. If you take 450 minus 360, you're left with 90 degrees. So it would go all the way up to your 90-degree spot. So that is how you would draw that angle. So to find this, you would take 360 plus 90, and you would get 450. So we're going to take 360, which is 6.4, plus 90, which is 1.6, and you will get 8.0. So that is the estimation for a 450-degree angle. And C, 690, one second. You would do one full circle. If you take 690 and minus 360, you're left with 330. So you would go all the way to 330, which would be over here. So that would be your drawing for that angle. So to find this, you would do 360 plus 330. And on your unit circle, you should know that 360 is 6.4. And to save time, 330 is 5.86. So altogether, you should get 12.26. 420 is one full circle, and 420 minus 360 is 90. 60, just kidding. I can do math. So it would look like this. So if you take 360 plus 60, you get 420. So 4 plus 1.06. You can add this one in if you want. Double 0.53, and you will get 7.46. For 495, we have our circle. You would go 360. 495 minus 360 is 135. So we'd go another 135, which is a 45-degree angle. So that would be 495 degrees. So if you take 360 plus 135, you would get 495. 360 is 6.4. 135 is 2.4. So this would be 10.8 or 8.8. And the last one is 660. So 660 minus 360 is 300. So you would go one full circle, and then you'd want to go to a 300, which is right here. So 360 plus 300 is 660. 360 is 6.4. 300, if you look at your unit circle above, is 5.33. And altogether it will be 11.73.